Hi, welcome back to How to Succeed in Physics on Distance, Velocity, and Acceleration. I'll be continuing my discussion of the OpenStax College Physics Problem 2.28, page 82, but I'll be working on Part B. Just to remind you of the problem, it asks, a powerful motorcycle can accelerate from rest to 26.8 meters per second. That's 100 kilometers per hour in only 3.90 seconds. And the question asks, what is the average acceleration and how far does it travel in that time? And we've already solved part A, and now we're going to solve part B. So this time, the things we know has grown a little bit. So before, we knew what the initial velocity was, that was 0. We knew what the final velocity was, that was 26.8 meters per second. We knew what the time was, and that was 3.90 seconds. And now we know what the acceleration is, and that's 6.87 meters per second squared. But the thing we don't know and that we're solving for is the distance traveled of the bike in that time. Okay, so to keep things organized, I'm going to put all of my knowns on the right-hand side of the paper, including my new acceleration. And I'm also going to add that x0 is equal to 0 meters. And what does that mean? It just means that I have a starting point, which I can call 0, and that the final x, which is on the left, which is what we're solving for, will just be the distance traveled. So it makes our life easier just to set x0 equal to 0. So now I'm going to look at my equations of motion and find the one that combines these six variables: acceleration, initial velocity, final velocity v, time t, x0, which is the starting point, and x, which is the thing I'm solving for. And if I look at them, I have actually two to pick from. So both these equations will work because the first equation, x, x0, v0, t, a, and then t again, we have all that stuff. The second equation has v, v0, a, and x0. But since the top one is already set up for us to solve, we already have the unknown variable on the left-hand side. Why don't we just go with that one? So now all that's left is that I'm going to insert the known quantities into the equation. So where x0 is, I put 0 meters. Where v0 is, I put 0 meters per second times time, which is 3.90 seconds. And then 1/2, 6.87 meters per second squared times 3.90 seconds squared. So I'm going to carry out the calculation, and it's important that when you do this that you keep your units alongside your number, okay? We don't want to drop them because they're important at the end. So I can cancel the first two terms because they're both just 0 or something multiplied by 0. And I'm just left with the third term, which is 1/2, then 6.87 meters per second squared, times 3.90 seconds, and that whole thing squared, which I'm just going to rewrite as 3.90 seconds times 3.90 seconds. So now I can take all my numbers and put them in one fraction, and then I can take all my units and put them in another fraction and solve them separately. So I just plug those numbers into the calculator and I get this 52.24635. And then I'm going to want to round that number to 3 sig figs, as I explained in the last video. And so that's going to round down to 52.2. And then for the units, I've got meters and then 2 seconds, units of seconds up top, and then seconds squared, which is the same as having seconds times seconds. And I'm going to cancel those and just be left with meters. So now we've answered the second part of the question, and that's just 52.2 meters. And we want to double check that our units make sense, and they asked for distance, and we gave them meters, so it's the right kind of units. And we feel pretty good about our answer.